Our macro expander recognized one special form with one special branch. A normalizer soon asks, is this a where inside another where? Is this and with true? Is this take inside take? Each transformation adds another condition, another extraction of pieces, and another reconstruction. The conditionals are becoming an accidental pattern language, but one that exists only in control flow. Make that hidden language explicit. A rewrite rule is data with a name, a pattern, and a replacement. The pattern says which tree shape is admissible. Named variables say which subtrees to remember. The replacement says how to assemble a new expression from those bindings. Evaluation maps expressions to values. Rewriting maps expressions to expressions. Place the merge pattern over this target subtree. Literal where nodes must line up exactly. Pattern variable outer binds the status test. Inner binds the date test. Source binds the entire transaction source expression. A variable can match one atom or a whole branch. The matcher does not need to know what a filter means. It only follows tree structure. If a pattern variable appears twice, both appearances must match the same subtree. That one rule lets a pattern express structural equality. As an x plus xa failed literal or an inconsistent repeated binding, rejects the candidate without constructing anything. Successful matching returns an ordinary binding map that we can inspect before the tree changes. Now read the replacement as a template. Put outer and inner beneath a new and node, then reconnect the bound source. The result is one where with one combined predicate. Substitution copies bound syntax. It does not evaluate either test, open the source, or guess what a variable should contain. The engine replaces that subtree at its exact path in the full query and records the step. Rule name, path, bindings, before and after. The normalized program is exactly our canonical type tree. Both versions execute to B, Chen, and D with the same totals. A trace turns a transformation from a mysterious jump into an auditable derivation. Change domains, not engines. Start with the expression open parenthesis x plus 0 close parenthesis times 1. A bottom-up strategy visits the addition first. The rule named add 0 on the right binds x and replaces that addition with x. Only the product remains. Now the rule named multiply 1 on the right matches the root and replaces the whole product with x. The matcher, binding map, substitution, path replacement, and trace are unchanged. Only the authored rules differ. This is the language building move again. Instead of teaching a function every algebra case with branches, we designed a small rule language and one interpreter for it. Differentiation can now become a collection of rules rather than a new pile of conditionals. Rules alone do not guarantee progress. One rule expands 2 times x into x plus x. Another factors x plus x back into 2 times x. Apply the first available rule repeatedly, and the term returns to where it began after 2 steps. Our engine remembers visited terms, reports the cycle, and stops instead of pretending it found a normal form. A practical rewrite system must choose more structure. Which rules point toward simpler forms, which node is visited first, what a result costs, and when to stop. Sometimes we want one normal form. Sometimes we want every alternative and a search frontier. Next, we take the easy, finite direction first. We express differentiation as rules, watch derivative values rise through a tree, and use the result as an independent verifier for the harder reverse problem.